All right.
Yeah. Pi day. We want pi days.
Yeah. We're gonna have to figure something out on that.
We could all get the vaccine for Pi Day.
I know I got my first one yesterday.
Yeah.
Which one did you get?
I feel fine. No, my arm hurts.
Did you get Pfizer or Moderna?
Pfizer
They're saying the first Pfizer is 92%.
is 92. Yeah. Cool. That's better than the
I
Moderna.
was thinking it was like 60. The second speech was 95.
But no, it's 92.
92 is like 90. Thank you, Pfizer.
Thank you.
Still have to wear this mask, I'm sure, though.
Yeah,
Yeah.
Yeah.
Still 8%.
I mean, just because like it's not 92% you're not gonna get it. It's 92% you're not gonna be hospitalized. You can still transmit it. Which,
Yeah,
like,
you can carry it.
I don't think anybody knows anything. We're just hard guessing right now.
I think they're all experts in a lot of things, but people study for 8 years as doctors, and then they go to they study these things, and they do studies, and that's how we got 90%.
I mean, if we've had pandemics before, it's not like the unknown.
Yeah, but we haven't given unapproved, FDA-approved vaccines
They
before.
literally got FDA.
They actually.
Not on one I signed
They didn't.
They
yesterday.
got emergency.
It said there has been no, I'll show you my little card.
They didn't, they didn't approve of the same.
Yeah. But whatever. Whatever.
Health is not politics. Health is science.
All right, guys. So, anybody have any questions with what we're doing at this point? You should feel pretty good about finding the area between curves, whether or not figuring out which curve is on top, figuring out where they intersect if you don't have a picture or a graphing calculator. And then, of course, please be brushing up on your integration. It really is painful when you get an AP problem. Most of the time, I'll be honest with you, most of the time, the area and volume, the big question that shows up on the AP test, most of the time, it is a calculator problem. But when it's not a calculator problem, you can get all the setup right, and then if you forget basic U substitution, you're getting 1 out of 3, 1 out of 4. You're just missing, and it's not like, listen, my integration test was so much more difficult than the vast majority. A few months since we integrated, but it's like people just, it's like their brain has checked out on U substitution. U subs to what? I mean, it's like there's no memory of it for some of you guys on basic stuff like sine of 3x, e to the 3x, 1 over 3x. It's like, well, maybe that'd be effective, 1/3 of it. You got to brush up on that. And if you're doing homework problems, you'll get brushed up on it, at least if you're checking your work a little bit. Well, anyway, today I'm going to talk about a different, subtly different, well, maybe not subtly, but every now and then, and AP's really good about this, they will give you a problem and they'll ask you for the area between the two curves, right? And you'll look at it and you'll get it all set up and it won't ask you for the volume. I mean, the area. It'll just ask you for the setup. And it's a multiple choice question. And you'll get it all set up and you'll go down there and you'll have done it correctly. And you'll look down your answers and there won't be any of your answer there. And you'll start noticing that instead of my integral in terms of all these x values dx, you see all these results in terms of y dy. And what that meant was, instead of finding the area between the two curves this way, they found the area between the curves this way. So instead of saying like from x value A to x value B, find the area between them, what they did was from y value A to y value B, find the area between them. And sometimes you won't even be able to, at least not with a lot of luck, you won't even be able to use your little top minus bottom method. Like they may give you the equations written in terms of y, and you can't resolve them in terms of x. Y'all know what I'm saying when I say in terms of?
No.
So like most functions are y, written function y equals some equation in terms of the x. But if I gave it to you x in terms of the y, they're basically forcing your hand unless you resolve, and sometimes you can't resolve. So today I just want to talk about how we actually do that integration in terms of y. And it's not difficult. You just have to change everything in your brain to, instead of x intervals, top minus bottom, y intervals, right minus left. Sorry, right minus left. Okay? And because the right minus left, the top minus bottom, because we're using the topmost, the biggest values minus the smallest values, well, right minus left would be the biggest values minus the smallest values. Okay? So let's just take a look at that, and we'll see what you think. I don't think you're going to see that it's a whole lot different. So I'm on page maybe 157. So let everything boot up here. Nope. So I'm on page 159. Okay, so here we go. Area with respect to y. All right, so the first problem I gave you up here, this is me solving it, and I gave you the graph of it so you can kind of see it a little bit better. The first problem right here, you can see the two functions, and I can totally go top minus bottom. In fact, why wouldn't you go top minus bottom on this? It just makes sense. I gave it to you as y equals. You can find that intersection point, happens to occur at -8. You can find that intersection point, it happens to occur at x equals 0, and you can integrate from -8 to 0 of the top function minus the bottom function. I go ahead and plug the functions in. Notice that's dx. And look, everything is written in terms of x. Are y'all seeing that? Now, do you really know what this integral is doing? I mean, I hope you understand that when you look at an integral like this, and just think about it with me. When you look at an integral like this, what is y top minus y bottom, or function minus function, giving you? Now think about it. A function, this is a y value, right? When you have the equation y equals 16 minus x squared. You have this equation, y equals 8x plus 16. So if I'm subtracting y values, what am I finding? So it's a length. That's it, right? All I'm finding when I subtract this function and this function is literally all I'm finding is a length. You could call it a height of whatever the difference is. And as you go from -8 to 0, what's happening to that height? It's changing, and that's fine because my height changes as my values change, right? Well, guess what dx is? dx is your change in x. If you think about that ugly definition of an integral that we had, where you were summing all the Riemann sums, remember? We had a limit and a sigma notation. We were basically taking all of those bases and heights, right? And each base times height gave me a little area of a rectangle, and then we were summing them all together. But we were doing an infinite number of them where the bases got smaller. Well, this literally is saying height. That's the height right here. And dx is like saying the change in the x. That's like saying a little base. And what we're doing is we're taking a bunch of base times heights. But the change in x right here, which is infinitely small, times the heights, when I sum them all together with that integral, accumulates all the little Riemann sums through here. But that's what you're doing right here. You're basically going height right here times your base, and you have an infinite number of them from an x value of -8 to 0. That's what an integral is doing. And if that makes sense to you, it's going to really make sense when we get to volume, because we're doing the same kind of things with volume, except we're now bringing in an extra dimension. But that's all I'm doing here. So right here, I know we're using y's, we're subtracting y's, but since y's are equal to a function that's made up of x's, you can see that my change in my x value is this, little changes in x's, times the heights, which are these, and give me all that. When you sum it all together, it gives me the area between the curves. I can do this same thing, not by going heights this way, but I could also do it heights this way. Are you seeing that? But to do heights this way, I'm not taking the y value of this and subtracting the y value of this. I'm taking the what? The x value of this, and I'm subtracting the x value of this. But to do that, I would have to have it written as x equals something y. So if I were to resolve these, check it out. Right here. Okay, so if I took these two equations that I had originally, and by the way, I would not do that here. I would not, unless my answer was not showing up as a multiple choice question, because I'm fine doing it the other way. You'll see how AP forces your hand or makes it maybe so much better if you do a right minus left situation. But look, if I solve for x here, I would have to move the x squared over, subtract the y, square root both sides. And when you do that, what do you get? What does plus or minus mean to you? They're actually what?
Plus or minus?
So that's two equations.
Okay.
There's x equals the positive version, and x equals the positive version of a square root gives you this part. X equals the negative version gives you a different part. Actually, it's a little bit different than that because these have been switched. But basically, it gives you the positive version and the negative version of that thing right there. Okay? And then over here, when you solve for x, I just subtracted the 16 and then divided by 8 and then wrote it as a fraction. But that would give me the linear function. Now, these are now x values, okay, in terms of y. So right here, if I'm thinking about not the heights top minus bottom, but if I'm thinking about the heights as or the width of this as a right minus left, I need to take this x and subtract this x. This x, actually the one on the right, this x, the linear one, and subtract this x, the parabolic one. Are you kind of seeing that? And when I do that, what are my variables?
Y.
They're y variables. So when I started out, what I'm really doing is I'm saying I'm taking this x equal equation, the one on the right, and I'm subtracting this x equal equation on the one on the left. And when I do that, that gives me that length, which we're kind of calling our height. But what is my base? My base is now a change in the what? It's a change in the y. So that's why I have to use dy. But it makes sense because when I take this line and subtract this parabola, that x minus x, since x is written in terms of y, you see nothing but y variables there. So I'm taking the y's there, subtract the y's there, and notice I'm using the negative one. And you don't see a lot of having to determine which one's positive or negative. That's just this example. But I'm taking the negative one there because there's a positive side of this parabola and a negative side. And I want to use the negative side because that's what's over there. Now, the next thing you have to change is I don't want from left to right. I'm doing it from bottom to top, right? Of the interval is. So you can't use 8 anymore, or negative 8 anymore. You've got to use the y value that goes with that. So you go back over there and you said, well, when x was negative 8, if I plug a negative 8 in where these intersect, either one, I get a y equals negative 48. So that's going to be my lower limit. And then when x was 0, you can't use x equals 0 anymore. So you plug a 0 in for x and you get y is 16. That's going to be my upper limit. Now again, if I can do top minus bottom, I'm going to do it. 9 out of every 10 problems you see on the AP test, you'll be looking at top minus bottom. You will see that. I really have to dig through the archives or make my own stuff up for right minus left situations, but they will occur. That's what separates the 5s from the 4s, maybe the 4 from the 3s, those little extra things that you do. So it's totally an AP topic. You're going to have to understand this, but you will see, I'll try to point out to you how AP will make your life really easy if you understand right minus left. But sometimes you can do it both ways like you could in this one. And I would never do this right minus left when I could easily, I don't even have to change the equations if I just go top minus bottom. Okay? But you'll see at the end, you get the same value, right? 256 over 3 there, 256 over 3 there. Y'all seeing this a little bit? Okay, so I have that written out for you, but here's kind of an example of how AP might set something up. It's not going to look like this, right? In fact, it more than likely would give you a picture so you wouldn't have to draw it, but I'm just trying to get you a little bit of practice just in case. So I said sketch and graph and find the region bounded by these two. Well, the great thing is it kind of begs you to do a right minus left situation because it's solved for x equals the y. So if it's solved for x equal y, we might want to know what these things look like. So I'm just going to plot some points in there. What happens when y is 0?
3.
X is 3. What happens when y is 1? When y is 1,
X is 2.
x is 2. What about y equals negative 1? Still x is 2. What about when y is 2? X is negative 1. What about y is negative 2? X is still negative 1. So I can probably sketch this thing just by plotting some points. You don't have to make yourself miserable. All right? Now, the other one you can resolve if you want, or you can still plot points. When y is 0, x is 1. When y is 1, x is 2. Oh, that's enough for that line. Now, think about top minus bottom here. For those of you that are thinking, oh man, forget this. I'm always going to do top minus bottom. What would you have to do to find this area if I was doing a top minus bottom? Think about it. I'm going to have to integrate what looks like from negative 1 to what?
3.
To 3. But what's going to happen?
At some point, change.
At some point, I have to change. So I'm going to be doing line minus the negative part about this parabola. And think about what you're going to have to do. If you try to do top minus bottom, you're going to have to do this. So if you were to do this, hypothetically, and you don't have to copy this down. I just want you to see the pain and the agony. For you to do this integral with top minus bottom, you would have to go negative 1 to 2. And then you'd have to take the line and subtract what? The negative part of the negative version of this. Put it in parentheses, dx. And then you'd have to take what? The positive part of the parabola, which would be the positive version, and subtract what? Itself, essentially, but the negative version of itself, you would have to do this. And you'd have to do that from 2 to 3. And I'm assuming 2 and 3 are right and negative 1, but you can check them and see that they are. So not only would you be forced to resolve these, but then you'd have to be really careful about the plus or minus as well, and you'd have all of that integration. But if you do right minus left, look, the right never changes. The left never changes. Are you following me? So all you have to do if you're doing right minus left, I think all of this is just terrible. If I do right minus left, I can say, well, that's the parabola, 3 minus y squared. That's the line, y plus 1. I'm going to integrate that from not negative 1 to 3, but from what? Negative 2 up to 1. And then don't forget, it's dy now, because everything's in terms of y. And you knock it out super simply. So most of the time, your situations will be set up to make your life more simple when you do this. But occasionally, they'll give you the option. And usually, if you're creative enough, not even really creative enough, if you're comfortable enough in both, you'll look at it and go, oh, wow, if I do top minus bottom, I'm going to have 3 integrals. If I do right minus left, I only have to have 1. Let's do right minus left. Oh, look at that. They were even nice enough to write it x in terms of y for me. So you'll see if you do the problems and get some practice with it. If you don't, there's a great problem in my test that I put on there every year. And it just wreaks havoc with people who try, they're like, man, I'm not doing right minus left. I'm good enough to do top minus bottom. And if you do top minus bottom on it, it ends up taking 4 integrals. And it's ugly and all kinds of ugly solving. You do right minus left, takes 1 integral. I mean, it's effortless. So if you understand both, I think you're going to be in good shape. But literally, that's the gist of what we're doing today. All right? It's just rethinking it and then making sure that if you're using y's, remember, got to have dy. And if it's a calculator problem, when you type it in your calculator, it doesn't matter what variable you use. I mean, as long as you write down y's right here, okay, your calculator, you can use all x's, you can use all a's, all c's, whatever you want, as long as your variable on your dx or dy or d, whatever matches the variable that's in the problem. All right? All right. What about this? Now, this is a great problem for you in that you can't solve for y. Think about it. How would you solve for y here? Actually, that's not completely true. You technically might be able to using a quadratic formula, but it would be awful. You'd end up with y equals a quadratic formula that had x values in it. It would be kind of nasty. I don't encourage that. Okay? But it's possible, but I wouldn't do it. And if I change that to a y cubed, then you don't even have that as an option. So, but you could still sketch it and get an idea what's going on. What happens if y is 0? What about if y is 1? What about if y is -1? -3? What about if y is 2? X is 0. You get an idea what it's doing now? So now that I kind of see, oh yeah, it's just kind of heading that way. And then the other one, x equals -y. That's not too much trouble. Just like y equals -x. But again, I got to be totally honest with you. There are not many problems like this where you have to do the graphing yourself. There just really aren't. Now look at top minus bottom. What would you have to do if I did top minus bottom? Not to mention be massively creative with your solving, because I don't know how most of you are going to solve for y like that. You're just going to go, what the heck? I can't do it. Like this, literally, this is what you'd have to do. You'd have to say, okay, I'm solving for y, where 1 is the a, -2 is the b, and x is the c. Literally, you would have to say y equals, and you have to do this, and you'll get an equation with an x in there, and that would be, and you have 2 of them because it's going to be plus or minus, right? That's what you have to do here, which is going to be a nightmare, and I promise you, if there's a multiple choice question, it will not show up, and the setup will not be an answer like that. It's just they're not making you do algebra like that, not since like 1993 or something. I mean, the algebra is much more simple these days. But look how easy right minus left is. Right minus left, the only thing on the right is that. The only thing on the left is this. So I'm going the parabola equation, right, minus the linear equation. And remember, I'm using y and y because these are technically x values. This represents the right x value. This represents the left x value. The change in x's is representing each of these individual heights. And if I multiply each individual, and they're not, I'm using height loosely, each of these individual lengths, right? And when I multiply those times a tiny little change in the y, a dy, each of these gives me a little bitty rectangle, and the integral sums them all from what to what? From 0 to 3, good. Not -3 to 1. From 0, from that bottom y value, up to this top y value. And again, don't take those for granted. I mark those points so I know they are, but always, if you can, find those points. This last one, pretty similar to this first one, and I'm getting bored. So I am going to jump to 2012, and we're looking at question number 2. So if you want to jump to 2012, question number 2. Remember, if you're at home and want to check your work on these, there is a link that will jump you right to this page. So 2012 free response. And you can click on the scoring guidelines and it'll tell you how they score everything, but I'm just going to go to here. All right, so here we go. 2012. You're going to be able to do part B. Actually, we can do C on this. So you could do A and C on this. You'd be able to get 6 of these points, hopefully at some point soon. And then you'll be able to get the last 3 by the end of next week. So here we go, region R. Now, if I look at region R, if I were to do top minus bottom, what am I going to have to do? If I were to do that, I'd have to integrate that one, right? And then I'd have to integrate that one. I wouldn't actually have to do a top minus bottom because the bottom is the x-axis, right? So I just have to integrate this function, and that would give me the area down to the x. And then integrate that function, and that would give me the area down to the x. And they set the equations up as y equals ln x and y equals 5 minus x. So you could totally do that. Shouldn't be a big deal. You are going to have to find what, though? If you were to do that, you're going to have to verify that that's at 1, verify that that's at 5, which is not a big deal to do. But you are going to have to find that x value to be able to go top minus bottom. So real quickly, to do that, I'm going to use an 84. If you were to graph the natural log of x and graph the 5 minus x graph, so I'm going to do it both ways here. If I were to graph that, I'm going to set my window.
Is this a graphing problem?
This is number 2. So yeah, number 2 would have been a graphing calculator problem. Yeah, otherwise you'll never be able to find that value. They would have to give that to you. And I'm going to go from 0 to 2. No, I'm sorry. I'm going to go from 0 to maybe 5.5 on the x. And for the y, I'm going to go maybe from 0 to 2. And that looks good to me. And here's what my calculator would give me. Now, again, this is me going top minus bottom. So based on this, right here, I'm going to have the integral of the natural log function. Is it just ln x? Plus the integral of the natural log function, dx, from 1 to, we're going to call that a, but I'm about to find it. So we're going to call that a. So from 1 to a, and then I'm going to add to that, from a to 5, I'm going to have the 5 minus x function. And then to find that intersection, second, calculate the intersection. First curve, yes. Second curve, yes. Take a guess, I don't know, 3. And it gives me the x and the y value. Now, I'm going to write these down and kind of walk you through again what I would do. So that point right there, you could say, I'm going to call it AB, and AB equals 3.693, and the B equals 1.3065. You can round those or whatever. And then this right here is going to be my B value should I do it the other way. And that's how I would label it if I was going to be using both X and the Y value. Now, if you have the Inspire, you can just highlight that, store it as A, highlight this, store it as B. It's not that lucky on the 84. So I'm using the 84. Now, I do know that what's been stored as X. That's right. So you can see that right here. If I quit this and I hit X, you can see that 3.6934. but the y has not been stored. So what I'm going to do, since I'm probably going to use these values over and over again, what I'm going to do is I'm going to do vars, y vars, function, y1. Doesn't really matter which one you use, right? And I'm going to take this and I'm going to plug that in to my function. So y1 of x, or you could do second answer at that point, and it's going to give you the y value. And then I can store it. Tell me if you're with me. I can store that as b if I want. And I can come up here if I want to, and I can take that 3 point whatever, and I can store that as a if I want to. So it's not a whole lot of effort to store them as a and b, but it beats writing down that y value from the screen. It beats writing it down because you're only going to see a certain number of, like right here when you calculated the intersection, look, you only saw, well, 7 decimals is probably fine, but you only see a limited number of the decimals. I always want to be exact to make sure I'm okay. To me, it beats writing it down, making a careless error. I'm just going to store it. And once I have it in there, I'm in great shape. I labeled that A, I labeled it B. I'm allowed to use A in this equation. Now, how hard would it have been? I'm sorry, if you're taking a multiple choice question and you look and this is not an option, and you're like, but I know I'm right. And by the way, this is what they'll do to you also. They'll give you something so close to this that you think, oh, maybe I just made a careless error. Like they really will. They'll make it x minus 5 instead. And you're like, it's probably me. They'll tease you with the right one, but then what they'll have is a bunch of options in terms of y. So if that happened, right, or in this case, how would I do this exact same problem, but this time do it in terms of the y value? Help me out. Keeping in mind that these are your y equals ln x, y equals 5 minus x. So how could I do this all in terms of y?
In terms of x.
So how would I do that? And these are things you have to know how to do. How do I solve for x here?
Exponentiate.
Exponentiate, nice. So I get x equals e to the y. How do I solve for x here?
Flip over to that 5.
So x equals 5 minus y. And now I'm ready to go again. So now all I need is one integral. So I want to integrate the line, which is on the right, minus this is now a kind of an exponential function in terms of y. You can see it rising up like exponentially, but up the y. Subtract the e to the y. Again, don't forget dy to group all that together. But this time I'm going from what to what?
0.
0 to b, which is your and you're going to see it on part C. Part C, they kind of force your hand on this. So you could have done it either way on part A, but on part B rolls around. And granted, if you've gotten 6 of the 9 points at that point, you'll see that this question B question is not a big deal once you learn it. But when you get to the part C, if you're like, oh, wait a minute, that's a little tricky, and I'll walk you through it. I'll almost promise you I'm going to give you a question like part C on your test. All right, the part C question is kind of really where you earn your money. So check out part C here. Part C. The horizontal line, y equals k. Now, wait a second. What is the horizontal line, y equals k? It says the horizontal line y divides that region into 2 regions of equal area. Now, it's got to be a horizontal line, right? So I'm just going to eyeball what I think that might be, although it doesn't really matter that it's exact. So maybe, I don't know, what do you think? Maybe something like that?
Maybe.
Maybe. So that's the horizontal line, y equals k. Divides it into 2 regions of equal area. The question is, write but do not solve an equation involving 1 or more integrals, so you have some options there, whose solutions would give k. So can you write an equation involving this with this k that would relate these two areas so that you could solve for K. And you don't even have to solve for K. Anybody got an idea? And remember, what has to be true here? The two areas have to be equal. Write that. How do you write the area? Pick one. Let's start with the bottom one. How do I write the area of the bottom one? Okay, so the integral, now think of how hard this would be trying to do it a different way. You don't know what K is. So if you try to do a top minus bottom, keep in mind what you're doing. If you tried to do a top minus bottom, you'd have to have that top and then that bottom. And then at some point that you don't know, this is going to switch and you're going to have this linear top and this linear bottom. And then you're going to come back and have that top and this bottom. It would be awful to even try to process that. But right minus left, pretty basic. So fortunately, we've already solved for these. So I can go right, 5 minus y, minus left, e to the y, group the whole thing dy, and that gives me the area as long as I go from what? 0 up to k. And then now, I'm going to go from k to what? B, which is 1.065. So now I'm going to go from k to b, which again, 1.0365, of what? Line minus line again. Line minus curve again. 5 minus y minus e to the y dy. And what do I know about these two areas? They have to be equal. Are you seeing this? Do you also see that if you actually had to solve this, think about it. If you actually had to solve this, you would have to simplify this and then integrate it, right?
Correct.
And then once you integrated, you'd be integrating from 0 to k, so you'd have to plug a k in, and then a 0 in, and then subtract them. So what variable would you have in the problem at that point? K. And then same thing over here. You'd have to simplify this, which is not much simplification, but because you're only subtracting that one thing, right? So right here, you'd have to take this, and you'd have to integrate this from k to b, which is 1.0365. And when I did that, then I would have to plug the b value in and then the k value in and subtract. And that would leave you another equation with what in it? K's. And you have an equation with a bunch of k's. And you could actually solve for that k by graphing. Although if it's me, you know what I'm doing right now if they ask me to solve for k?
Assuming the position.
No, man. Brings pain and suffering.
Walking out of the AP room.
Come on, guys. Somebody in here. I'm using my calculator. Guys, I'm holding it. It's not like a pillow, right? It's in my hand, right? If it's in my hand, how can I solve any equation at any point in time if I have my calculator? Graph it. How do I graph this? Yeah, you do.
Yeah, you do.
That was subtract one.
Yeah, I can subtract this to the other side, which would negate it, set the whole thing equal to y, and just graph this sucker. Now, you'll notice AP didn't ask you to do this. Why? Because you poor saps with an 84 might be sitting there a while. But you could do it, right? Yeah, and if you have an Inspire, it's just going to go, and it's going to spit it out.
Can you graph it? If we don't know what K is, can we still graph it?
Yeah, but here's the thing. When I graph it, my calculator doesn't have an XK axis, right? So I need to make my K's my what?
X.
My X's. Does that make sense?
Then what about the?
Because I'm solving, when I graph it, I'm solving for X. So make your K's your X's.
So does that mean your Y is your?
Now, I'm going to show you both ways. It should not matter what these are, because like we said, if we were to integrate what we're going to put in, we're going to put X's there. The X would go in for that, right? And all you would have left is X's. But I also know this, I've checked, and if you just make them all the same, all X's, it's fine. But I'm going to do it with the Y's in there, and I don't think my calculator is going to wig out, but we'll see. But again, you didn't have to do this, but I just wanted to show you. So graph, delete, menu, window, what do we say, 0 to, oh yeah, that's not a good one. 0 to 5.5 on the X, 0 to 1, was it 1.5 we had? Yes. Okay, and then tab, so here we go. The integral, I'll show you how I have it set up. The integral from 0 to X, because I want X's to be my variable, because I'm going to be solving for X, right? That's how my calculator works. And I'm going to come down and I'm going to do 5 minus, I'm going to try Y, just see if it works, so that but I know it'll work if you put X's in there. E to the Y dy minus, whoops, you got to jump out, you got to go right one step, minus another integral of k, which is my x, and since I don't have this stored, I'm just going to type in 1.3065, and that's going to be 5 also minus y minus e to the y dy, and I'm going to hit enter. 1004. Minutes match. See it graphing it? You'll see the dots showing up.
Not really. Oh wait, there we go.
It's going to think. It's going to start filling them in, I think. Or not.
Dang.
Now, it doesn't give me the answers to this because it doesn't care.
For the odds of my calculator.
Oh, did you hit? Oh, you can always hit on and stop it. Yeah.
Oh, there you go.
Oh, there it is.
I have a line,
So far, he's got a line.
Oh, I tried to graph.
Okay, so right here, remember, I went from 0 to 5.5, so I can see 2 places, according to this, where the x values would be true. That doesn't really make sense to me right there. And let me see if it looks different if I put x's all the way. So if I go up there and I put x's all the way in here, okay, yeah, you can see my calculator struggling with trying to function.
Probably all those games you downloaded on this.
So here's me changing everything to X. It might be able to think more quickly that way. Actually, form-wise, it's not. Oh, and if I change everything to X, I need to make it dx. Ah!
No.
You could hit the undo button.
Oh, you're right.
I'm always right.
No, that's not helpful. Because now it has to rethink. Oh, wait, I didn't hit enter, so there it is. Delete X. It might be a little quicker thinking all one variable. So that might be the way you want to go if you ever have to do this. We'll see in a second. Let's see if it crosses at the same 2 places roughly. So this is it rethinking. And if it still crosses at these 2 places, right around in here, wherever that was. Yeah, so it works either way. So if it makes you more comfortable just to put all x's in there, and it takes a while to think, and I wouldn't do this with an 84, is it still spinning?
Yes.
Yeah. But again, AP made it nice on you. Hey, is there any other way you could have done this? Rather than go, hey, this integral is equal to this integral. Can you be creative?
No.
Yes. You just plug it all in.
What else could you have done?
You can
Instead of saying this area 1 equals that area 2. Couldn't you say that this area 1 is what? If it's half, I mean, if it's the same as this, isn't it half the total? And you just found the total in problem 1, didn't you?
Yeah.
So you could have said, hey, this area right here is half the total area that I found in problem 1, and you found problem 1 to be 2.986. And if you had done it this way, that would have been way easier to graph. Because now all you have to do is move over that value and set this equal to y. Calculator can think a whole lot better. But that one risk in doing it this way is, well, if you screw up problem A, AP readers may or may not. They should be able to go, oh, they took that. If you could have said from part A and just kind of show them that you're using that. So in case you made a mistake, they go, oh, they were just using bad information, but their thinking was good. Are y'all seeing how they can kind of force your hand like this? You're going to have to know both. You're going to have to know both. And if you know both, this, guys, it's a pretty easy test. I mean, especially if you've done homework problems. We haven't gotten to probably the most difficult part, the cross-sectional area, but even that's not bad if you understand what you're doing here. Like if you understand right here that when I subtract the functions, I'm finding a height and I'm multiplying it by a little bit of width in the dx or the dy. If you understand that, then when you start doing volume, it's not a big deal. Well, in my opinion. All right. I'd strongly encourage you to be checking out some of these homework problems. Anybody think they got that part C right? Had they not just seen it?
I probably would have.
You might have.
Yeah.
I
If you would have,
would have liked to hear.
great. But just keep in mind there are other problems like that show up on this test that I'm giving you a glimpse at through AP problems. So through other problems.
Yeah.
All right.
Oh my God. Not expecting that.
That's a Pokemon.